All right. So, before we get out today, I'll show you on Canvas, but that second homework assignment should be up there now. Just have a little bit of an issue for some reason. I could see it in here, so you guys couldn't. So I got that solved kind of yesterday. So start trying to kind of work through those earlier problems in that. It goes back to like equilibrium, but also kind of elasticity stuff we're doing. So when we're doing elasticities of demand, we were saying how responsive is quantity demanded, right? So what's in our numerator? How responsive is that to percentage changes? And actually here, percent changes, I guess. So I'm going to be really with my notation, right? And percent changes in price. So how responsive is quantity demanded to changes in price? So we can do similar things, right? So if I want to do like a cross price elasticity, maybe I'm thinking about, well, how responsive is the quantity demanded for good X, right? When I see changes in the price of either substitute or complementary goods. So, right, we know that if the price of, say, a substitute good goes up, what happens to the demand curve for the other substitute, right? So substitute good, the price goes up, right, of some other good Y. What happens to the demand for X? We said that would, if Y is now relatively more expensive, I will want to buy more or less of X. More, right? So demand would increase. So you think about this cross price elasticity, we're looking at the percentage change in quantity demanded for good X. But now it's not from a price change in good X, it's from a price change in good Y. So we can do this cross price elasticity. So match the notation. So demand in good X, and that percentage change in price in good Y. So let's think about what the cross price elasticity is telling. So I can still put it in the range, thinking about 1 is my cutoff there, where, you know, if I take the absolute value, if it's greater than 1, I would say it's elastic, right? Less than 1, it's inelastic to this other goods price changing. But more so what we'll use this cross price elasticity to measure. Let's think about it this way. So I've got, now instead of demand, right, it's a cross price between goods X and Y. Right, because before, when I wanted just to, you know, how does the percentage change in quantity of good X change to a percentage change in the price of good X? Well, now I'm interested in how does the quantity of X change in, you know, response to good Y's price change. So if there's substitute goods, right, then when I see an increase in the price of good Y, we just said that that should increase the demand for good X. So right, they would both be kind of increasing, or they would both be kind of positive changes. Well, positive over positive, if the cross price elasticity is positive or greater than 0, that's telling us these are substitute goods, right? As the price of that other good goes up, the quantity demanded from the good that I'm looking at, good X, is also going up. Okay? This is the idea of substitute goods. It's becoming relatively more expensive to buy good Y, so people buy more of good X. So if we ever see this cross price elasticity is positive, we know that there's substitutes. Well, what if I see that when the price of a complementary good goes up, right, the price of a complementary good goes up, what happens to the demand for good X? The idea of, like, if I'm looking at electric cars and the electric car battery price goes way, way up, what's going to happen to the demand for electric cars? It goes down, right? It's relatively more expensive now to use it. And so I would see that go down, a negative over a positive. This would be less than 0. And this would be evidence then. I'll get out of the way here in a second. Right? This would be evidence that they're complements. If I see a cross price elasticity that's negative, I know that relationship would exist for complementary goods. So if I see a cross price elasticity less than 0, I would say that these are complementary goods. Okay? You see that, all right?
Yeah.
So that's the cross price elasticity. Just looking at the sign of it will tell us whether or not these goods are complements or whether or not these goods are substitutes. Any questions on this? And if we had some actual values, you tell me, well, the price of good Y starts at $10, it then increases to 15. As a response, previously the quantity demanded for good X was 100, now it's 120. It's the same idea. We can use that midpoint method to then figure out, okay, what was the percentage change in the price of good Y? What was the percentage change then in the quantity demanded of good X? Right? But really here, more so what we're going to be focusing on is kind of the direction of the changes, right? Whether or not the percent change is positive or negative. Here, we don't want to just take the absolute value like we did with the cross price elasticity of demand, like we did with the price elasticity of demand, because we always knew that was going to be negative. Price and quantity demanded for the same good always move in the opposite direction. Here, depending on whether or not they're substitute or complementary goods, looking at the price change of good Y and the quantity demanded of good X. So those could work in opposite directions, could work in the same direction. Questions about this? Okay with this? So we can do the same thing for income, right? And it's not a whole lot different in the sense that if I want I think here typically, kind of moving forward, we'll have some topics we'll start using. Usually we'll write income as M, and it's just kind of convention in economics. I is usually reserved for like inflation and things, so we started using M for income. Right? Well, if I've got a percentage change in the quantity demand for good X, and I'm thinking about, okay, now I'm not interested in how responsive is demand to changes in the price of that good, but changes in income, right? So I wrote the word up there, but we typically use M to kind of represent income as well. So anytime we're talking about elasticity, it's how responsive is something. Well, up to this point, and what we'll kind of focus on is, it's going to be how responsive is the quantity demanded, or in a second we'll see we can also do quantity supplied, right? But how responsive is the quantity, right, to whatever changes are in the denominator. Originally we started out with, that was how responsive is quantity to changes in the price of good X. Then we looked at how responsive is changes in quantity to changes in the price of good Y. Now we're thinking about how responsive is it to changes in income. Okay. So if income goes up, and then subsequently we see the demand for that good also goes up, this would be the definition of what type of good. When we're thinking about income and how it shifts the demand curve, we said there were two types of goods. If increases in income causes people to buy more of that good, we say it's what? Normal. Yeah, right. I think it might be up there on the screen, right? So, right, if we see that they move in the same direction and that income elasticity is positive, that tells us they're normal goods. If when income goes up, we see that quantity demanded goes down, well, that is going to give us a negative value, right? And this was kind of the definition of inferior goods. When you have more money, you buy less of them. So the sign of the cross price elasticity told us about whether or not they were substitute or complementary goods. The sign of the income elasticity of demand will tell us whether or not they're normal or inferior. Okay? And once again, how do we calculate these percentage changes? The exact same way we did before, using that midpoint method. Take the difference between the old and the new quantity demanded, divided by the average quantity demanded. Take the difference in the old and new income, divided by average. Well, the average between those two income values. Questions on this? I'm not working through like examples with numbers because I think we did a lot of that with the price elasticity of demand. It's really that same procedure, right? The last one we'll talk about, kind of wrap up elasticities, and we won't talk about them for the rest of today, I don't think. So would be the price elasticity of supply, right? So just like with demand, right, we can say how responsive is quantity demanded to changes in the price of that good X. We can also say how responsive is the quantity supplied to changes in the price of that good X, right? So here we're not using subscripts or anything because we're not interested in different goods. We're not interested in income. Here, we're interested in price changes and quantity supply changes of the same good, right? So if you really wanted to, you could like put X subscript and X, superscript on the quantity, but we're talking about the same good. Okay? Just we're talking about supply now instead of demand. So where demand, we knew our price elasticity was always going to be negative, right? Because price and quantity move in opposite directions. For supply, our elasticity of supply should always be what? If the price goes up, what's going to happen to quantity supply? It goes up, right? If the price is higher, sellers like that. They want to sell more of that good. So they're always going to move in the same direction, or vice versa. If the price goes down, they want to sell less. So they're always moving in the same direction, a positive over a positive change, or a negative over a negative change. So we know that it's always going to be positive, and then we basically put it in the same range as we did for demand. Less than 1 would mean that supply is inelastic. Greater than 1 means supply is elastic. Equal to 1 would be unit elastic. Okay? Now we probably focus a little bit less on the elasticity of supply because really, if we think about decision making for most companies, like they are the supplier, like they already know what they're going to do ahead of time. It's usually focused on the price elasticity of demand because we want to know what our consumers going to do. When I change the price of this good, how are the consumers going to respond? Because that's how I'm making my money as a company, right? But we can do the same thing for supply, right? If I'm interested maybe in what are my competitors going to do if the price goes up for this good on the market, then I might focus a little bit more on the price elasticity of supply. Any questions? Like I just kind of introducing. It's really the same sort of stuff. And I guess the way to think about elasticities is always how responsive is the thing in the denominator to change. Sorry, how responsive is the thing in the numerator to changes in whatever's in the denominator, right? So here, the price elasticity of supply, how responsive is quantity supplied to changes in the price of the good. Income elasticity, how responsive is percentage change in quantity demanded to change in income. Cross price, how responsive is quantity change, is the quantity good X to change in the price of some other good Y. Right? And then I don't know how far back I have to go to get probably way too far back, but here we go. How responsive is quantity demanded to change in the price of that good X. Right? So we've got several different kind of elasticity measures. The next thing that I want to go over, I left a blank slide because I kind of skipped this, I guess, so to speak. We talked about the equations. I gave you the visuals of the equilibrium. And kind of behind, combine all the things we talked about, you can come up with this, but I didn't explicitly work through it, so I want to do that now. So let's say I had 60 4Q, right? And this represented my demand curve, and then we'll do, I'm going to put this up at the top of my head, so I changed demand, I lied to you. We'll do 80 minus 4Q is demand, and price is equal to 20 plus 2Q will represent our supply curve. Okay? So we talked about, we have equations for supply and demand. These two values, 80 and 20, would represent the intercepts, right? And then -4 and 2 would represent the slopes of those two curves. We always know that for demand, we should have a negative slope, right? And for supply, it should always be positive slope.
Do you have an audio issue in here?
Other than me? I don't know. No, we didn't have any issues. I don't know about the previous class or whatever. Okay. Okay. What was I saying? Oh, the slopes, right? We know are negative and positive. So what we could do, right? And this is where I kind of jump to, maybe skip the intermediate steps. But if I'm trying to graph supply here, the first thing I would say is, okay, at a quantity of 0, where does kind of where would my supply curve start out? Like, what price will give me a quantity of 0? Right? Well, if I plug in 0 into my quantity, 2 times 0 is 0, plus 20. I know that my intercept on the y-axis for supply is at 20. Right? At that quantity of 0, the price is going to start out at 20. At the price of 20, no one's willing to supply anything to the market. As I kind of think about what price would it take for that first unit to be supplied, well, the price it would take would be whatever the marginal cost of that first unit is. Well, we said the supply curve reflects marginal cost, right? Eventually, when I get the supply curve, it's going to reflect marginal cost. So this price that I would need to supply that first unit is really just telling me, well, I would supply it if it was equal to my marginal cost. So it's also supply curve is telling me the marginal cost of different units. This is where we said if I plug a 1 into here, the supply curve would tell me the marginal cost of that first unit. If I plug a 2 into there, the marginal cost of the second unit. I can start plugging these different quantities and like plot those points. So right, 2 times 1, 2 plus 20. So I would be like, okay, at a quantity of 1, 22, plot that point. Plug in the quantity of 2. 2 times 2 is 4 plus 20. All right, so to get the quantity of 2 on the market, that would require a price of 24. I just go through and plot all these points, right? Until I would have like my entire supply curve. Does that make sense what I'm saying, right? If I'm just plugging in different quantities into my supply curve, I can figure out the price that would be required to see that quantity on the market, quantity supplied on the market. I can do the same thing for demand, right? Where does the demand curve intersect the y-axis? Well, when a quantity is 0, right? I would be at a point of demand 0 times 4 is 0 plus 80. So my demand curve starts up here on the y-axis at 80. And then I could plug in a quantity of 1. 4 times 1 is 4. 80 minus 4 is 76. So at that first unit, the demand, I would plot that from 76. Do the same process, plug in all these different quantities, and I eventually end up with kind of this downward sloping demand. So behind all these visuals that we had when we were looking at the equilibrium, behind all this supply and demand, where they intersect, there's really 2 equations that represent those lines. Okay? And the reason why those lines are where they're at is because we're literally graphing a function. We're graphing the function of demand. We're graphing the function of supply of whatever we're looking at. Right? So if I'm then telling you, okay, the equilibrium price and quantity are right here. I can identify that graphically. Like if you give me a graph, maybe I can tell you the values, but I don't even need the visual. All I need are my equations. Excuse me, because what I'm really saying is equilibrium is the point where quantity demanded is equal to the quantity supplied. Or we're at an equilibrium price such that the marginal cost of that last unit supplied to the market is the same as the marginal benefit of the last unit supplied to the market. Right? This idea that we do things as long as the marginal benefit is above the marginal cost up to the point where they're equal. It kind of, we said that's how individual decision making operates, but that's also basically what plays out in the market, right? The marginal benefit of that last unit consumed in the market will be equal to the marginal cost of that last unit supplied to the market. So really all we're saying here is it's the price at which quantity demand is equal to quantity supplied. And notice here it would be the same price on the supply and demand curve. So we're going to set supply equal to demand. We can actually just do something like this. Here's our demand curve. Here's our supply curve. I just set those 2 equations equal to each other. Right? So it's going to be the point where those 2 functions or those 2 lines give me exactly the same value. There's no other quantity here where supply and demand will give me the same value. If I'm out here, demand is going to give me a much different price than my supply curve. Because that's reflecting the marginal benefits of these higher quantities are much lower than marginal costs. So at this point, it's just a little bit of algebra, right? So I can subtract 20 for both sides. I get 2Q is equal to 60 minus 4Q. I'm then going to add 4Q to each side. Just moving through the algebra here. This is going to give me 6Q is equal to 60. Divide both sides by 6. And I end up with quantity is equal to 10. What is this quantity representing? My equilibrium quantity. Right? So once I set those two equations equal to each other, I'm just solving, right, for the one thing I don't know, which is, well, what quantity would make these two things equal to each other? So now that I've got a quantity of 10 as my equilibrium quantity, what's my equilibrium price? Well, it's going to be the point that I'm at on either my supply or my demand curve, right? So I just go up. If I plug that quantity of 10 into either my supply or my demand function, it should spit back out at me the price that will be required to get that 10 units. So once I solve for my equilibrium quantity, I plug that back into either my I plug that equilibrium quantity back into either my supply or demand curve, and that'll give me my equilibrium price. I always think supply is a little bit easier, just because to be completely honest, it's easier for me to add in my head than I think subtract for whatever reason that is, right? So if I plug 10 into here, 20 plus 2 times 10, right? So if I want my equilibrium price, I'm just plugging that quantity of 10 into my supply equation. So 20 plus 2 times 10 will give me that equilibrium price of 40. Okay? So that's how we can use mathematical formulas, right, to solve for that equilibrium quantity demanded, or sorry, equilibrium quantity, equilibrium price. We don't need to just rely on our visuals. Okay? Any questions on that? It's a little bit of a step back. What about we use the same equations, but now what if I told you so we know that the equilibrium quantity was what? 40. And equilibrium quantity was 10, equilibrium price was 40. What if I told you that, what's the value of the surplus if for some reason the price here is set at $30? So if the price instead of that equilibrium price of 40, let's say I set the price at $30. Am I going to have a shortage or a surplus here? I think I already said it. Huh? Oh, sorry, because you're right. I was thinking of setting a higher price, and I said a lower one. So if I set a lower price, right, I go over, the quantity supplied is much less than quantity demanded. So if there's more demand than there is supply, we say we would have a shortage, right? The only way we end up with a surplus is if I had like chosen a price like 50 or 60, something like that. So we've got this shortage. Well, what's the value of the shortage? How could I find? I'm thinking about, what's that gap, right? What's that difference between quantity demanded and quantity supply? Well, if I know the price, right? If I plug 30 into my demand equation, it's going to tell me quantity demand. So I go ahead and take my demand equation and I plug in that price of 30. Now I have a little bit of algebra to do to solve for what that quantity would be. Once I plug that in, I could do it, right? So I think if I plug in that price of 30 to demand, so 80 minus 4Q, a little bit of algebra, so I get 4Q is equal to 50. Divide both sides by 4. Kind of doing a lot of this in my head here, but try to. I just do my algebra to solve for what that quantity would be. I figure out at a price of 30, my quantity demanded is 12.5. Well, then how do I find my quantity supplied? Well, I've got this price, the quantity supplied would be the point that I'm at on my supply curve at that price of 30. So similar idea, plug in my price of 30, solve for the quantity there, right? I'm running out of room, but I don't think we need this, so I can move out of the way there. So we plug in that price of 30 to our supply equation, which was 20 plus 2Q. I do a little bit of algebra, so minus 20 from both sides. Divide both sides by 2. I get that quantity supplied of 5. Well, now that I know my quantity supplied and my quantity demanded, the value of that shortage is just the difference between the two. So we really can use these equations to find like any point on our supply or on our demand curve, right? If I'm giving you a price and I'm interested in the quantities, just plug them into the equation. If I give you a quantity and you're interested in the price, we just plug in the quantity into that equation, solve the price. So, I know everyone's math level is a little different, but if you're not super comfortable kind of doing this algebra of solving for the unknown, maybe kind of, trying to work through more of these examples on your own is going to be helpful, because I am going to kind of expect that we can do this like pretty, basic level of kind of algebra, solving for just one unknown. Okay. Don't worry, we won't have like to solve for like 3 or 4, multiple equations, multiple unknowns. It's always going to be one equation, and we're just solving for the one thing we don't know. We'll jump into this. So we're going to start working through things that the government does that screw up the markets. Right? So this will be kind of a reoccurring theme as we start to work through more of this, that free markets seem to arrive at these pretty optimal locations for society, and then government comes in and they make some rules, and we end up at points that aren't as positive for our society. So price floors and ceilings, quotas. We already talked a little bit about price floors and ceilings. We'll go through a little bit more in depth today. So we'll then go to taxes and subsidies. We'll introduce the ideas. I think I've already briefly mentioned it, but we'll really elaborate on consumer and producer surplus, right? And how all these government regulations alter kind of the benefits to consumers and the benefits to producers, which will kind of introduce this idea of deadweight loss, which is like how much this government regulation hurts society, right? Deadweight loss is basically what we're missing out on. All right, so we'll first think about price ceilings. These aren't too bad. A price ceiling, right, is if you tell an industry, you can't charge a higher price, or when this good is purchased, the price can't be greater than a certain value. So examples of this are during wartime, sometimes certain commodities, they put a price on, kind of cap the price on. Maybe rent controls, right? We don't want rent to get too expensive, so we tell these major cities, you have to kind of keep rental prices below this value. And so we might have these examples where we see a price ceiling, right? The government comes in and says you can't charge a price above this. So if we're thinking about what this is going to look like, right, and maybe we're thinking about rent, right, apartment and rent control. Right? So if you kind of impose a cap on the price, right? Right. So we start out with our equilibrium. What we're going to identify, so from this equilibrium point, right, the price of a apartment is $1,000 a month. Right? That's our equilibrium price. At that price, we can start to identify things called consumer and producer surplus. So I think the visual I'll give to you. So anytime we have a market where we've got demand representing marginal benefits, I think this maybe helps the idea. So let's say we've got some equilibrium price out there. Consumer surplus is going to be the total benefit to all consumers in the market from the consumption of this good. Well, what is each individual unit's surplus, right? So when you think about surplus exists over every single unit, right, up to that equilibrium quantity in that market. But every single unit sold might have a different surplus because the first unit provides a really, really high benefit to the consumer that's way, way above what it costs that consumer. What's the cost of the consumer? Whatever the price of that good is, right? So for these first few individuals or these first few units sold, however you want to think about it, right? The surplus, the difference between how much they benefit, remember, the demand curve shows us the additional benefit to that person. And then the price is essentially the additional cost. Right? So the difference between those is what we're calling surplus. Like almost think about surplus as like net benefit, right? The difference between how much it benefits me and how much it costs me. Well, for every unit sold, right, that surplus value starts to become smaller and smaller and smaller. But if we're interested in all of consumer surplus, it would basically take every single surplus at every quantity sold and add them all up. So the area underneath the demand curve, but above the price consumers are paying, essentially represents all of consumer surplus. So from the consumption of apartments, I guess in this example, the consumer surplus that exists is that blue area, right? The area above the price that consumers are paying, but below those consumers' marginal benefit, which is reflected by the demand. So we would call this area usually just CS, right? Consumer surplus. For producer surplus, right? Price is actually a good thing, right? That is the benefit to the producers. The cost to the producers is, well, whatever the marginal cost was of providing those additional units. Right? So for each unit, you can imagine for producers, the benefit is price, the cost is represented by that supply curve, what the marginal cost of providing that good was. So you kind of think about for every unit, we're going to have producer surplus down here. And then if we add that all up, the area that represents producer surplus would be the area below price, right, below their benefit as well, but above their cost. Their cost is kind of this marginal cost reflected by the supply. So we're really looking at like net benefits for both consumers and producers. It's just that for consumers, their benefits are the demand curve, represented by the demand curve. Their costs are the price, right? So here is the difference between their benefits and their costs. For the producers, the benefit was the price they're selling the good for, and their costs were kind of reflected by the supplier. So that's why those areas represent producer and consumer surplus. Yeah, I mean, I think it's you can kind of see when we're at that equilibrium point, right? It really total surplus would just be the area between the supply and demand, right? So if I took producer and added consumer surplus, total surplus would just be everything in between that demand and supply curve. So it's kind of easier to find those areas when we have like a lack of regulation. We're just breaking a free market and we can arrive at an equilibrium point. Because really I'm just finding the area of what? Two triangles there. I could find consumer surplus here. I don't think it doesn't quite show me the value. I'm guessing this is like 1600 where I hit that y-axis. Well, if I go from 1600 to 1000, I've got like the base of my triangle. If I'm then going from a quantity of 0 to 2.0 or 2 million here, but I could use that too, right? I would have the base of my triangle. I'll have to find the area of a triangle, which is base times height times 1/2. Right? So as long as I have the actual equations and I can graph this out here, how would I calculate consumer surplus here? So the difference between the price and the marginal benefit. So we do this. The height, the height is going to be 40, right? The difference between 80 and 40 is 40. The base goes from 0 to 10. Right? So 40 times 10, so 400. Then it's a triangle, so I still have to multiply it by 1/2. So 400 times 1/2 is 200. So I can calculate the value of these surplus of this surplus if I have the actual equations. Okay? or I'm given the numbers in a visual graph. Okay, any questions over anything with that before we kind of continue to look at price ceiling?
So the consumer and producer are sort of at odds with each other.
Essentially, right? Because it's not necessary, they're at odds if we're thinking about the same quantity has to be purchased, right? Because then as I increase the price, you can think about that's going to be bad for consumers, but good for producers. But it's not a zero-sum game in that any gain in producer surplus has to be a loss. Sorry, how would I say it? Any gain in consumer surplus doesn't have to be a loss in producer surplus, because if we imagine both of these curves shifting so that we can also move the equilibrium quantity, then potentially there's an outcome where we both can increase surplus. But you're right, if we like fix quantity and thought about changing the price, then yeah, it's more of a zero-sum game there, where consumer surplus losses would kind of be met with producer surplus gains. That was a good question. Any other questions kind of related to this idea? Okay, so we start on this equilibrium. Let's say a price ceiling is imposed, right? So the equilibrium quantity for rent was $1,000. The government comes in and says, look, no one can afford to live in this city, right? We want our citizens to be happy. And so we're going to say you can't charge anything more than $800 in rent, right? So everyone cheers, like everyone's going to live for cheaper, right? Well, the problem is at this new price ceiling, I can't get to the equilibrium point. So what's going to happen? Well, at a price of $800, there's going to be fewer people who are willing to supply, rooms for rent, right? Or when we think about it that way, there's fewer people who are willing to build some new apartment complex, because if they know they can only get $800 as opposed to $1,000 a month, it's not a profitable apartment building to build, right? So at this lower rental price, right, we're going to see that quantity supplied is actually lower than what it was at the equilibrium point. But at that lower rental price, there's a lot more people who are wanting to buy or kind of rent an apartment that's only $800 as opposed to $1,000. Right? So essentially what we have, and kind of introduce the idea with the equations, and really call it that, but anytime there's a price ceiling set below that equilibrium, it's going to cause the quantity supplied to be less than quantity demanded. So these price ceilings will cause a what? Shortage. There's more people who want to rent apartments than apartments being supplied now. Okay? So yeah, if you're one of the, there's still 1.8 million apartments out there. So if you're one of the 1.8 million people, you're better off, right? You're paying less in rent and you still have an apartment. However, if you're anybody kind of in here, that 0.2 million people who now don't have an apartment to rent, well, now you're worse off, right? So some people benefit from this price ceiling, but the people that don't are essentially now potentially homeless. Even if they were willing to kind of pay that higher price. So kind of an interesting counterintuitive result where we're trying to help the consumers out here, but we've actually kind of only helped certain consumers. I don't know if I have. Yeah, so here, let's just try to think about how we've helped some consumers. So by lowering that price, new producer surplus is the area below that price and above the supply curve, or above their marginal costs, right? So we can see here, producers were kind of hurt by this, and that makes sense, right? The sellers of apartments, if you lower the price of an apartment, they're going to be worse off. Right? But for consumers, I can think about they gain, right? The individuals who are still able to purchase an apartment or rent an apartment, well, potentially they're, for these 1.8 million people, their surplus before was the difference between the demand curve and $1,000 of rent. Well, now their benefit or their surplus is the difference between their demand curve and $800. So for those consumers who are still able to rent an apartment, they're better off. Their surplus increased. But for all consumers, right, it's likely that we see there's potentially a loss, because when you think about for anybody in this range, right, any consumers here, they're no longer renting an apartment, so their surplus now is essentially zero, right? So anyone in this range, we kind of lose out on whatever surplus they had before. Also, for all these quantities above 1.8 million, we now have producers that if we allowed the market to be in equilibrium, they would have been deriving some surplus from selling those units, but they no longer supply those units to the market, so we lose out on this producer surplus as well. Right? So, so what we'll call that loss relative to the equilibrium is going to be deadweight loss, right? So the surplus, right, if we think about total surplus when we were in equilibrium, total surplus has went down by whatever this area is here because we're no longer selling these additional units. So we've got some deadweight loss to society. But we did transition a pretty good chunk of producer surplus before to now being consumer surplus. Right? So some consumers were hurt in this market, some of them benefited, and the producers definitely were hurt. We see a pretty great reduction here visually in producer surplus. Any questions on kind of this? And we'll work through some examples next week of equations. But can you, so if we're looking here, how could I, and instead of thinking about these as millions, if you just want to kind of think about this as like 1.8 and 2, that's fine for right now. How could I find the value of deadweight loss? There's actually two ways I could do it.
The base would be 1200 minus 800, and the height would be 2 minus 1.
Yeah, right. If I think about, if I'm keeping demand linear, right? So this deadweight loss area, that's going to be a triangle. Think about the height of the triangle, however we're thinking about base and height, doesn't really matter. But the height is going to be 1200 minus 800, right? So 400 height. The base, we're going from 1.8 to 2, so 2 minus 4.8 is 0.2. Base times height times 1/2. I could find that value of deadweight loss there. What's another way I could find deadweight loss if I didn't want to use the area of this triangle? It's kind of a different way of thinking about it. It might be a little bit more work, but it kind of, I think it lines up with a better intuitive way of thinking about this, of what deadweight loss represents. So if I had already calculated producer and consumer surplus before this price ceiling, and then add them up to get total surplus, and then I calculated producer surplus now, as well as calculated consumer surplus, which I can break consumer surplus down here to one rectangle and one triangle, right? So if I can find the area of rectangles and triangles, which hopefully we can, right? Just triangle base times height times 1/2, half rectangle, length times width, or base times height, however you want to, what terminology you want to use. I could figure out what consumer surplus is now, what producer surplus is now. If I add those up, that's the total surplus in the market, and deadweight loss would just be the difference between that total surplus and what total surplus was before the price ceiling, right? And like I said, that would take a little bit more calculation, like a couple more calculations, but that really is what deadweight loss represents. The loss in surplus from some kind of regulation, not necessarily from the government, but from some, some force that's not allowing us to kind of get to that equilibrium point. Okay. Any questions on that before we keep moving? We have time. All right. Do I have any questions here? Let's see if I have a. Maybe we'll see this. I'll introduce price floors and then we'll, no, I still have price ceilings. Okay. We'll finish up this and then we'll kind of start next class probably with some iClicker stuff. Yeah.
I do have one question.
Yeah.
Actually. So if we assume that it's a government mandate, over time, does the equilibrium price then shift towards that 800 because producers realize that there's no way around it?
if the government's mandated this, right?
Yeah.
You literally couldn't charge a price over 800 without potentially paying some fee. Right? So you might think about what's going to happen in a market like this, where you still have, what, 200,000, 0.2 million people who want to rent an apartment. So what do you think might happen? Instead of like doing things by the books and paying taxes, people might start renting apartments kind of without like meeting any of the codes or standards, right? Or doing this kind of under the table, right? So a lot of times when you have these price ceilings that cause shortages, here with the rental one, it doesn't make quite as much sense. But let's say, I don't know, this is legal now. So let's say I put a price, let's say I put a price ceiling on marijuana, right? In a state that it's legal, right? So you'd still have all these, so people that can buy it now, are like, ah, sweet, I'm paying a lower price. This is great. But there's still people who want to purchase it. But at this low price, there's no one who is wanting to legally supply that good, right? Because essentially you almost think about it as like, these aren't really their costs. Their costs would be whatever the regulations that are fees they have to pay if they want to charge above that price. So what might happen is you still have producers here who would be willing to supply that product, but they need to be getting a price over 800. So what might they do? Go through like the non-regulated means, right? Basically selling the product underground. So as long as you have like a price ceiling or something causing a shortage, you basically are incentivizing there to be an underground, like what we call black market, right? Where people are selling this without these regulations. It's a good question. Another question? So some examples of where we see price ceilings. We know they cause shortages. We know that they'll lower the price. They can cause black markets. They're wasting resources essentially because we should be up to that equilibrium point. We're losing out on additional surplus. And in order for them to be binding, they have to be set below the current equilibrium price. So if I go back here, if I put a price ceiling of $12,000 or $1,200, what's going to happen in this market? Well, the current equilibrium price is $1,000. So if you tell me you can't charge more than $1,200 in rent, I just go, okay, yeah, I'm not. I'm only charging $1,000. So if you did put a price ceiling above this equilibrium price, basically nothing's going to change in the market, right? At least initially. Over time, maybe if demand and supply shift, eventually it will be what we call a binding price ceiling. Maybe eventually the equilibrium price would go past that 1,200. But as of right now, the equilibrium price is 1,000. Setting a price ceiling above that does no good. So ineffective price ceilings would be this idea of you set it above the equilibrium price and basically causes no changes to the market. So I think we'll probably revisit price ceilings, calculating surplus, and then move to other government regulations. Think about deadweight loss. I think I mentioned last class, but that tentative date we had for the exam, I'm pushing it into the future an entire week. So I'll put up an announcement on Canvas today that our exam is basically going to be, I believe it's October 1st, that Friday in class. So we've got a little bit of time. We're going to kind of wrap up material next week and then kind of use that week of the exam, that Monday and Wednesday, to do a little bit more review and things like that in class.
Is it on paper or computer?
It'll be here on paper. Yeah. Yep. All right. That's another questions for me. Let you guys get out of here. Have a good weekend, and I will see you on Monday. Yeah.